ओके, सो प्रेशर का मेन काम क्या है? बिकॉज ऑफ प्रेशर fluid elements exert normal contact forces to each other. So let's say this is my first fluid element and this is my second fluid element. These two fluid elements are going to exert push forces, the contact forces. If you remember, contact forces are push forces that is exerted perpendicular to the contact surface. But कितना force लगा रहे हैं? How do we calculate that? That is calculated using pressure at that particular point. So pressure की वजह से force लगता है, correct? So how do we calculate the force due to pressure? So very important formula. This is the formula which we are gonna use throughout the chapter from now. dF perpendicular is equals to P times dA. Now important thing to note here is this is just the push perpendicular force. This is the push force, this is the perpendicular force exerted by the liquid element. There is no parallel component और उसका that is equals to P times dA. P is the pressure at that particular point. जिस point पर हम force निकालना चाह रहे हैं, हमने pressure at a point बताया था. What do you mean by pressure at a point? उस point पर कोई भी छोटा dA element लो in any direction. Find the force exerted on that dA. dF by dA would be pressure at that point. And this is same irrespective of the dA taken in any direction. उस dA को आप किसी भी direction में लो at that particular point, the force calculated would be same. Hence the pressure would be same for all directions. So उस particular point पर हम बोल देते हैं कि वो ही उस particular point का pressure है. So dF perpendicular is pressure at that particular point into dA, the area element, or F perpendicular. So this is my dF element, and if you need to find the total force acting on an area A, you just need to integrate this PdA over the entire area A. So this is the formula which we will be using. So two important conclusions from this. अगर मेरा प्रेशर पूरे एरिया में यूनिफॉर्म होगा, सो इंटीग्रेशन में P बाहर आ जाएगा, इंटीग्रल dA वुड सिंपली बी A, सो माई परपेंडिकुलर फोर्स वुड बी P इंटू A. परपेंडिकुलर फोर्स का मैग्नीट्यूड वुड सिंपली बी P इंटू A, द प्रेशर एट दैट एरिया, एट दैट सरफेस एंड एरिया. इफ द एवरेज प्रेशर इज नोन, सो पूरे एरिया में यू डू नॉट नो द प्रेशर माइट बी वेरिंग, बट द एवरेज प्रेशर इज नोन टू यू. So F perpendicular, the magnitude of the perpendicular force would be P average into A. Now, यहाँ से see, whenever we talk about force, there are three things associated with it. Its magnitude, then its direction, and its point of application. Correct? So magnitude of a force, so this force due to pressure, उसका magnitude कैसा आएगा? It would simply be P times dA, PdA. Now why is this the complete magnitude? हमने तो कहा था कि this is only the dF perpendicular. See, अगर हम fluid elements की वजह से force calculate कर रहे हैं, which is actually the force because of pressure, so dF parallel is actually 0. Because there is no parallel force because of fluid elements, since our fluid is non-viscous fluid. So parallel force आएगा ही नहीं. See, the only force is perpendicular force. So उसका पूरा magnitude comes from the perpendicular itself. So magnitude is simply P times dA. Direction में हमने बात करी थी. It is perpendicular push force to the area. So जिस एरिया पर हम फोर्स निकाल रहे हैं, इट इज परपेंडिकुलर टू दैट एरिया एंड इट्स अ पुश फोर्स. थर्ड इंपॉर्टेंट थिंग इज पॉइंट ऑफ एप्लीकेशन ऑफ फोर्स. सो हम जो ये फोर्स निकाल रहे हैं ओवर दैट एरिया, ये किस पॉइंट पर लगेगा? ना पॉइंट ऑफ एप्लीकेशन टर्न्स इनटू इफेक्ट जब हम बात करने लग जाते हैं रोटेशन की, करेक्ट? बिकॉज हमने देखा था अगर हमारा सिस्टम ही सिंगल एक पॉइंट का है, सो पॉइंट ऑफ एप्लीकेशन ऑफ फोर्स मेक्स नो सेंस. बट हमारा सिस्टम जब मल्टीपल पॉइंट्स का होता है, लेट्स से दिस इज माय सिस्टम, सो देयर आर अ लॉट ऑफ पॉइंट्स इन माय सिस्टम. जब हम बात करते हैं एक पर्टिकुलर फोर्स की, सो इफ यू आर अप्लाइंग अ फोर्स हियर और इफ यू आर अप्लाइंग अ फोर्स हियर, दोज टू हैव डिफरेंट इफेक्ट्स बिकॉज देयर टॉर्क्स आर डिफरेंट. सो पॉइंट ऑफ एप्लीकेशन ऑफ फोर्स निकालने के लिए one thing you have to remember is point of application of force is decided by balancing the torques. So this is actually a very general idea that if you have, let's say this is my system, okay, so let's say this is my system which I'm considering, and there are lots of small forces. So let's say this is my df1 acting at this point, this is my df2 acting at some random point, this is my df3 acting at some random point. Now you have calculated, now you need to calculate the net effect of this force. So this is my system, and there would be a net force F net. Now how do you calculate this F net? It's F net, its magnitude and direction is simply given by df1 perpendicular plus df2 perpendicular plus df3 perpendicular. This is easy to see, right? Total magnitude क्या होगा उनके sum का. So vector sum of all the forces would give me the vector F net. But how to calculate its point of contact? ये जो F net force है वो मेरे system पे कहाँ लगेगा? So that is calculated using balancing of torques. So what do you need to do? Take any point. So let's say this is point A, and tau due to F net at the point A should be equals to summation of all the tau vectors due to dfi's at point A for all I. So basically it's simply saying that take any point with respect to any point, calculate the torque because of these small df forces, calculate the torque because of this F net force, this F net vector, and it would be applied at that particular point at which these two torques are same. So basically you need to balance the torques. Okay, so pressure की बात कर ली हमने, pressure की magnitude की बात कर ली, that is PDA. It's a perpendicular push force and the point of application is calculated using balancing of torques. Fine. तो यहाँ तक हमने देख लिया कि fluid elements हैं, fluid elements आपस में forces लगाएंगे, force perpendicular होगा, there is no parallel force, perpendicular to the surface, it's a perpendicular push force. और वो force calculate कैसे करेंगे? That is calculated using pressure. df perpendicular equals to PDA. So fluid elements force लगाएंगे, calculate using PDA. Point of application is calculated using balancing of torques. हमने fluid elements के forces निकालने के लिए हमने जब शुरू में बात की थी the various types of forces in a free body diagram. If you remember, the first was mg, then we had normal forces, and we have pseudo forces, which is F pseudo, right? There was no tension and there was no friction force. These are the three types of forces जो हमें चाहिए हमारे fluid element को complete करने के लिए. Our main goal is to be able to draw the FBD of fluid element, because if you remember the main goal, cylinder बनाओ, Newton's laws लगाओ. In order to apply the Newton's laws, you need to calculate the forces applied on my system, right? So there are only three kinds of forces: mg, normal, and pseudo forces. mg forces कहाँ लगाना है, कैसे लगाना है, we know. pseudo forces कहाँ लगाना है, कैसे लगाना है, we know. The only thing which is bothering us is normal forces. So जब fluid element हमारा system है और उसकी जब हमें FBD बनानी है, फिर न्यूटन्स लॉस लगाने हैं, सो इस फ्लूइड एलिमेंट में कौन कौन से नॉर्मल फोर्सेस लगेंगे, कैसे नॉर्मल फोर्सेस लगेंगे, उन सबको जानना इज आवर मेन गोल. नाउ फोर्सेस निकालने के लिए वी नीड टू हैव थ्री थिंग्स: मैग्नीट्यूड, डायरेक्शन एंड पॉइंट ऑफ कॉन्टैक्ट. मैग्नीट्यूड इज गिवन बाय प्रेशर P into dA. So our final goal is how do you calculate this pressure, right? हम इस pressure को calculate कैसे करेंगे? Now once you know how to calculate pressure at a particular point, you would know how to calculate the force at a particular point, और फिर हमारी FBD complete हो जाएगी and we can apply the Newton's laws and we can do all the rules. We can apply then further all the rules of mechanics on our fluid elements.